Hello everyone, welcome to my another vlog. So for today's vlog, we'll be doing a additional discussion of the different type the different types of models here, which is the OSI model, TCP or IP model, encapsulation and decapsulation, and also the ARP process. Okay, first things first. The first one will be the OSI model. Okay. So it is said to be the Open System Interconnection or OSI model defines a networking framework. So it is a networking framework to implement different protocols in different layers. So it is said to be it has a 7 layers that will be discussed afterwards. So this handy guide to compare the different layers of the OSI model and understand how they interact with each other. Okay, so, afterward, the said Open System Interconnection or the OSI models said to be defines as networking protocol framework, and also the OSI model said to be it doesn't perform any functions in the networking process. Okay, so it is said to be conceptualized framework and conceptualize a conceptual framework, so we can better understand the complex interaction that is happening in this model. Okay, so we'll be also discussing who developed the OSI model. Okay, so based on my research, the International Standard Organization or ISO or ISO, they are the one who developed the open system interconnection or the OSI model. So it is said to be it divide the communication into 7 layers, but we'll be going to each one of them afterwards or later. Okay, so in this model, layers 1 to 4 are so so in this model po, 1 to 4 are considered the lower layers, and the 5 to 7 are called the upper layers contains application level data. So um, the network the network operates one basic principle. It is said to be the pass it on. Okay, so each layer takes care of very specific job and then passes the data onto the next level. Okay, in this point we'll be discussing what the 7 layers of the OSI is. Okay, so we have layer 7, the application, layer 6, presentation, layer layer 5, session, layer 4, transport, layer 3, network, layer 2, data link, and layer 1 is the physical. So, in a OSI model, control is passed from one layer to the next. Okay, so that is the hierarchical um, guide of it. So control is passed from one layer to the next, starting at the application layer. So application layer is at the layer 7. Okay, and after that is the OSI model takes the task of, so the OSI model is the one who are taking the task of internetworking. So this model is the one divides that up into what is referred to be the vertical stack that consists of the said layers. Okay, so a what do you call that one? I'll just share you with you guys that most of the functionality in the said OSI model exists in all communication system. Although three or two OSI layers may be, what do you call that one? Incorporated into one. OSI model is also referred to as a OSI reference model, or or just an OSI model. Okay. So for the layer 7, so I said it away. while ago that I'll be going to discuss it each thoroughly. So let's go to application 7 or layer 7 application. So in this layer, it supports the application and end users processes. So when you say application in the OSI model, it is the layer 7. So it is the one who supports the application and end user processes. Also, it is the communication partners are identified. Quality of processes um, that is identified. Users and notification and privacy are considered. Okay. After that is layer 6, which is the presentation. So this is the one who provides the independence from difference into a data representation. Example, encryption by translating from application to a network format and vice versa. Okay. Layer 5, which is session. So in the session 1, it is the one who establish, manage, and terminate connections between application. Transport or for the layer 4, it is the one who provides transparent transfer of data between end user or host and is responsible for end-to-end error recovery and flow control. So it is the one who ensures that or it ensures complete data transfer. Um, let's go to the chapter. Let's go to the network, which is layer 3. So this one is the one who provides switching and routing, and also it is the one that creates logical path known as the virtual circuit. Moving on, data link will be going to data link, which is the layer 2. So it is the data packets are encoded and decoded into a bits. It furnishes transmission protocol knowledge and management and handle errors in the physical layer. Last one for the 7 layers of OSI model. Layer 1, which is physical, it conveys the bit stream electrical impulses, light or radio signal through the network at, what do you call that one? At the electrical and mechanical level. Okay, so that you know guys that there is two similar projects from the 1970s. Okay, so 1970s, we are really going back in time. Were merged into 1983. 1970 to 1983, so almost 18 years to the basic reference model for open system interconnections standard, which is the OSI model. It was published in 1984 as standard iOS 7498. Okay, so I think that we are already done in this OSI model. Let's go to the next one, which is the TCP and IP model. Okay, TCP slash IP model. So here it is. So like OSI network model, TCP or IP also has I'm sorry. TCP or IP also has a network model where TCP and IP was on the path of development when the OSI standard was published and there was interaction between the designer of OSI and TCP or IP standards. So the TCP IP model is not the same as OSI model. So OSI is a 7-layered standard but the TCP is or IP is 4-layered standard. Okay, so what are those layers? So we um from the OSI model we have 7 layers, but here in TCP or IP we have 4 layered standards. These are the application layer, transport layer, internet layer, network access layer. Okay, so um, after that one is it is said to be the OSI model has been very influential in the growth and development of TCP or IP standards. So the OSI model becomes a foundation for the TCP or IP model and that was why OSI terminology is applied to TCP or IP the following. Okay, so after this one, um, we have a four layer here in the TCP or IP. So what are those? So layer 4, which is the application layer, it is said to be is the topmost layer of the four layer four layer TCP or IP model. Wait, okay. And application application layer is present on the top of the transport layer. Application layer defines TCP or IP application protocols and how hosts program interface with transport layer. Next one is the transport layer. Transport layer is the third layer of the four layer of TCP or IP model. The position of transport layer is between application layer. So this is the application layer, transport layer, and the internet layer. So it is in between the two. The purpose of transport layer is to permit devices. So its main goal is to permit devices on the source and destination host to carry a conversation. So transport layer defines the level of service and the status of the connections used when transporting data. Next one is the layer 2 internet layer. So for the internet layer, it is second layer of the fourth layer TCP or IP model. The position of the internet layer is between network access layer and transport layer. Internet layer pack data into data buckets known as IP datagrams which contain source and destination address. Okay, so the main protocol include a layer, internet layer or IP, the Internet Protocol, ICMP, or the Internet Control Message Protocol, ARP, which is the Address Resolution Protocol, the RARP or RARP, Reverse Address Resolution Protocol, and the IGMP, Internet Group Management Protocol. And for the last layer, it is the Network Access Layer. So it is the first layer of the 4 TCP model. Network layer defines detail of how data are physically sent through the network, including how bits are electrically or optically signaled by hardware devices. Okay, so um, in this discussion for the TCP or IP, we we learn about the four layers of TCP or IP model and comparison between four-layered TCP or IP model and the seven-layered OSI model. Okay. Next one, wait, I'll be doing. Um, okay, so we've known what are the differences between the OSI and the TCP IP model. Also, those layers that is part of it. Next is the encapsulation and decapsulation. First one is encapsulation. But wait, I'll be just giving you some sort of preview or overview of this one. So it is said that data is very important for every organization. Therefore, it is necessary to send data to another location easily with a minimum amount of time. So the data can be sent to the destination using the network. A network is a collection of interconnected devices such as computers, printers, for sharing resources. For sharing resources becomes complex and resources when there is a large number of hosts. Okay, so let's move on. Wait, okay, let's move on. Encapsulation. So it is excuse me. So encapsulation is the process of adding information to the application layer data as it is sent through each um, model data. So each time the data passes a layer, a new protocol data unit or the PDU is created. Okay, so now it is known as the frame. Likewise, in each layer, a corresponding protocol data unit or the PDU is created. Um, Also, this one, for a better understanding, so assume sending an email. Okay, so assume yourself that you are sending an email. The email is created as an application layer. So the email itself is the application layer. The email should pass. So this will be the email. The email should pass the layer transport layer, or the yeah layer transport layer, internet layer, and this will be the layer in the layer transport layer, the internet layer, and the network access layer. So using different protocols and interface, um, and relay protocols and out the computer using wireless or wired network interface, then the email travels through the network and comes to the destination. Then the email goes to the network access layer, internet layer, and transport layer, and to the application layer in order. Okay? Next one is the decapsulation. So decapsulation is the process of opening. Okay, so we'll talk about the encapsulation. So encapsulation is this one will be encapsulated, but decapsulation is this one will be open. Opening in encapsulated data that are usually sent in a form of packets over a communication network. So it can literally be defined as a process of opening a capsule. This will be the capsule, opening a capsule, which in this case refers to the encapsulated wrapped up. Okay, so when it's sent to the network layer, it is a packet that has data, TCP or UDP header and header with IP address. Then the packet reaches the transport layer. Now it's segmented and contains data. And TCP or UDP header, finally the segment reaches the application layer. In the application layer, and the host can see the data sent from the source computer, and that process is known as decapsulation. Okay, so to give you a better understanding between the different key difference between the encapsulation and the decapsulation, it is that in encapsulation, the data moves from the upper layer, this will be the upper layer, to the lower layer, and each layer includes a bundle of information known as a header along with an actual data. While in the encapsulation or decapsulation, the data moves from lower to the upper layers, and each layer unpacks the corresponding headers to obtain the said actual data. Okay? Um, we are now talking about the decapsulation and encapsulation, and how 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 does those differences create a major impact to the network today. Okay, so we come to the last part, which is the ARP process. ARP process, or ARP, which stands for Address Resolution Protocol. ARP is one of the major protocol in the TCP or IP suite, and the purpose of Address Resolution Protocol (ARP) is to resolve an IPv4 address 32-bit logical address to the physical address 48-bit. Okay. So first things first, what is the purpose of the ARP? So the purpose of the ARP, or the address resolution protocol, is to find out the MAC address of the device in your local area LAN, or local area network, which is LAN. Okay, for the corresponding IPv4 addresses which network application is trying to communicate. Also, um, there are different messages formats here. Example, these are the following fields in the address resolution protocol message format. We have here a hardware type, protocol type, hardware address length, protocol address length, um, opcode, sender hardware address, sender protocol address, target hardware address, target protocol address, and so on and so forth. Um, okay, so, and this one, okay, okay, so in that way we known for the fact that what is a real purpose of the ARP, or the address resolution protocol, what are the different message format incorporated with it, specifically the address resolution protocol. Okay, so to summarize this one, we've come to the end of this video, because we've already done in discussing all of the four said topics, which is the OSI model, TCP or IP model, um, encapsulation, decapsulation, and the last one is the ARP process. Okay, thank you guys for watching.